The question we are solving now belongs to test series 2. It is of control system subject. In specific, it belongs to root service analysis of control systems. As per question, the characteristic equation of a closed loop control system is given as s power 4 plus 2s cube plus 11s square plus 18s plus 18 is equal to 0. We need to find the number of poles that are strictly on the LHS of S-plane. So, from the given characteristic equation, the root array can be formed as shown. First, we form the root array entries corresponding to s power 4 and s cube. The row corresponding to s power 4 will have the coefficients corresponding to even powers of s, that is 1, 11 and 18, and the row corresponding to s cube will have the entries corresponding to odd powers of s, that is 2 and 18. Now we get the entries corresponding to the row s square as shown. So the entry at the point mod can be obtained as 2 multiplied by 11 minus 18 multiplied by 1 divided by 2, that is 22 minus 18 divided by 2, that is equal to 2. Similarly, the entry here can be obtained as 2 multiplied by 18 divided by 2, hence the entry will be 18. Here we see that the rows corresponding to s cube and s square are the same, which makes the other entries corresponding to the next row as 0. So just to avoid this, we form the auxiliary monomial for the row corresponding to s cube as a of s is equal to 2s cube plus 18s. So now we substitute for the entries corresponding to s square row by dA by ds, which evaluates as 6s square plus 18. So the entries in s square row are modified as 6 and 18. Please note that this issue has arisen because there are some poles exactly on the omega axis which can be obtained from the auxiliary polynomial. So from this we see that now the entries corresponding to the row s can be obtained as shown, that is 6 into 18 minus 2 into 18 divided by 6, that becomes as 2 by 3, and the entry corresponding to 1 can be obtained as 2 by 3 multiplied by 18 divided by 2 by 3, hence 18. So from this we see that the number of sign changes is equal to 0, hence all the poles are on j omega axis or on LHS of S plane. Here we see that the total number of poles is equal to 4 and the number of poles on j omega axis is equal to 2. From this we can say that the number of poles on LHS of S plane is equal to t minus n j omega, which evaluates as 2. So from this we see that the number of poles which are strictly on the LHS of S plane is 2, hence the correct option representing the number of poles on the LHS of S plane is A.